Yeah, let's start. Welcome to the first presentation of this afternoon of our ACES at Home online conference. It's already the third afternoon and today's topic is databases. My own presentation today focuses on my learnings, as Johnny already said, and some preconditions of deployment automation. It will show you how you can start when you want to automate your installations of your database applications. And it shows what you need and where you should begin with your automation. So when you want to introduce some optimizations in your development process and you don't know where to start, this presentation is exactly for you. It will also show you what the problems are while automating. And if you have questions during the presentation, please ask them in the Q&A panel. I try to answer them at the end of the presentation. There should be enough time for questions afterwards. Now, something about me. My name is Jasmin. I'm a database developer, and since last October, I'm part of the Oracle ACE program as an ACE associate. I work mostly in data engineering and focus on efficient development processes. Therefore, I deal a lot with automation and the tool chain. My topics that I work with are mostly testing and continuous integration. I do also program some PL SQL, and I work a lot with data warehouses and data marts. You can find me on Twitter if you like to follow me. And I also have a blog on Medium where I write blog posts, very irregularly though, but you can follow me as well if you like to be notified about my irregular blog posts. So now, before we automate things, we first need a baseline on how the development process looks like. So we can talk about the same thing here. The development process you see here applies to all kinds of systems. So you don't necessarily need to be a developer to stay and look at this presentation. It's also for all the system engineering people and the DBAs. And the things I tell you today not only applies to Oracle databases, but for all other databases as well. Some things are special with databases, but others aren't. So the process applies not only to the development of software, but also the development of systems or the development of infrastructure. It starts with the planning icon, where you have something of an idea what to do. What we will discuss today is how you can organize the 5 steps in the middle: coding, testing, reviewing, deploying, and monitoring, so that automation of the deployment step here is possible and helps you to improve your development processes overall. Now, what do I mean with manual deployment, or how do you know if your development processes have the potential to be improved? How do we know if we lack efficiency? You can detect inefficiency in your processes if you have a lot of manual tasks that you need to do until your changes finally make it into production. You detect those manual tasks if you need to write emails to get things going, if you need to start scripts manually to get things going, and all this is not fun. I mean, being at the end of a mailbox is not fun, and so isn't asking for stuff with emails not fun. You can also detect those manual tasks if you need to do handovers. Maybe there's this other department that you need to contact to get things going. Maybe there's this one person that you can only deploy to production. Those are handovers and therefore manual tasks and breaks in your process. And that slows you down a lot. Maybe you have to wait for minutes, maybe for hours, but maybe you also have to wait for days until things get going. A third characteristic of such manual tasks, if you have dependencies to other people or departments to get things going. If you need a lot of coordination, this might be an indicator that you aren't at the best performance possible regarding your processes. So if you have to involve different people, you have too many dependencies for an efficient development process. So when you are automating and optimizing your deployment processes, your goal must always be to eliminate all the manual tasks. You need to eliminate all the handovers to other people and eliminate all the dependencies in your process. That's the main goal. Now, why do people not complain when their processes are really inefficient and waste a lot of time? Deployments might be painful, they might require a lot of coordination, or installations could be unreliable. Packages are big, they often contain wrong code, coordination is huge, many emails, many versions of packages. Also, manual version control on network drives or local hard disks isn't convenient and leads to mistakes as well. But why do they not complain when this is obviously something wrong here? You accept your workarounds because they work for you. People get usually used to the time they need for certain things and mostly don't question it, why it is that way. Eric Evans called this legacy blindness at a domain-driven design conference a couple of years ago. He said that legacy blindness is when you get used to workarounds because they work for you. And I think this defines the phenomenon pretty good, that people don't complain about the process they work with because they work for them at the moment, and people get used to the time those processes take them and don't question it. Now, are there scientific facts about team performance and software delivery? I also publish papers myself and really like when things are founded on research and when things are peer-reviewed. I'm not a big fan of esoterical theories and unfounded propositions, so this presentation will contain some scientific facts. If you see a blue slide with a white atom during this presentation, it's a scientific fact. Most of those facts are out of this book. It's called Accelerate, The Science of DevOps by Nicole Fosgren, Jess Humble, and Gene Kim. It's actually a fantastic book if you want to know why you should do something about your software delivery performance and how the software delivery performance impacts your business performance. It's for all kinds of businesses, not only IT organizations. Because there's no business without a proper IT. If you want to have other book suggestions, you can also ping me. I can give you some as well. So blue slides with the atom are the scientific facts. Now, why is automation so important for us? The goal in development and building systems is to achieve stable releases with high quality. With stable releases and higher quality, we should be able to achieve less unplanned work. And this step not only involves deployments, but many other preconditions around the development process. Now, what do we need and what are the preconditions for this deployment automation? Let's go back to our process. To be able to automate the deployment step, we need to establish some preconditions before in the other steps as well, in coding, testing, reviewing. We will now go through those individual steps and look at the preconditions and how to improve the process in those tasks. Now, let's look at the first task. What are the preconditions for this first step? What do we need to do in the coding step? We are here. Let's look at coding. So first, science says that high performance is possible with all kinds of systems. And the team and delivery performance is independent of the technologies the teams use. So if you ever hear someone saying, yeah, for me it's impossible to increase productivity with technology XY, yeah, that's not true. It's not depending on the technologies you use. It is possible with all kinds of technologies to have a high performance. But you need some preconditions, as I said before. The first one would be maintain a single source repository. You should have only one repository for your application source code. And all your application source code belongs into that one repository. What you also shouldn't do is having one repository for multiple applications. I see that a lot in projects that people mix that up, but it should really be a one-to-one relationship. And why is this so useful? Why is a version control system so useful? I am not talking here about any particular version control system, but you should have any version control system. First, you can enforce discipline amongst your colleagues because they need to check in their changes in one single place and also get the latest changes from that one single place. And that makes them being a bit disciplined about the code. You always have archived versions of your source code, what makes you sleep a lot better at night. You don't have to worry what happens if your laptop dies or someone deletes your network file share. That's all not your problem anymore. The third point is you can maintain historical information and you can find people that implemented something you don't understand because the history of your version control doesn't forget. This is also very useful. You can find people. Another precondition is that you store all the application artifacts in your version control system. So all the artifacts belong into that one repository of your version control. Now, what exactly means all the artifacts? Which one belong really in there and which ones don't? We have here two categories. The ones that belong into version control, that are all the source code files. So your application source code, everything that you code. All the scripts and other files you need to build or install your software. So everything related to the installation to your software belongs into that version control. Also your text documentation, markdown or license files. If you write documentation, it's always good to have them as text documentation and not use some binary artifacts that are hard to handle. All the configuration files of your application belong into version control and all the other text files you have that your project needs. But there are artifacts that don't belong in there, like generated files and build artifacts, jars, vars, reports. Also log files don't belong in there because those are all generated and they will generate again if you build the application. Also IDE specific configuration files shouldn't go in there, and all the binaries, like binary documentation and other binary files. Now, a third precondition is that you think about the size of your feature that you implement. The goal here is to keep your branches short and your features small. What is a short branch? Short branches are branches that have a short lifetime. The branch lifetime is measured from the creation of the branch until the merge of a branch into the trunk. On this image, you can see the trunk as the blue master branch, and you see two feature branches. We can assume both feature branches are short-living branches because they contain only 1 and 2 commits. And to achieve this, you have to think about the size of the feature when you plan it. So you can't have an implementation of a big feature that needs a lot of time and do that with a short-living branch. You obviously would need more time and probably also more commits to do this. So try to keep it as easy as possible, one functionality at a time, and then merge it back to the trunk. Now, what does science say about coding? It is proven that high-performing teams have shorter integration times and shorter branch lifetimes. So if you keep your branches short and build one functionality at a time, you have a perfect baseline for automation and for getting faster with your development process. It is also proven that working in small batches enables faster feedback. Of course, because if you deliver a small amount of functionality, you can deliver it to the customer and receive direct feedback on the new functionality. The last precondition of coding is that you should use a proper IDE. A proper IDE makes it easy for you to work with your version control and work with your application artifacts. You know if you have a proper IDE, if you don't have to leave it for the development of new features. If you have to switch between applications to get all the functionalities that you need in your development process, your IDE is probably not up for the job. You should probably switch it then. And my personal assumption is the reason so many database people are struggling or are not using version control at all is due to its bad implementation in the common database IDEs. They don't really make it easy to use and often add more complexity than necessary. Now you have your IDE and your version control set up. How should you write your migration and Delta scripts so that they are ready for automated deployment and installations? What I see often is that people are not aware that migration scripts need to be decently robust. They need to include logging, they need to be restartable or repeatable so that they can be executed multiple times without damage to the system. Because if the first run goes sideways, you need to be able to apply the same script to the database without your changes that previously were successful sending errors now. So migration scripts also should be self-validating, that they check if they are executed on the proper schema, that they check if the migration was already done before and isn't starting a second time. And migration script should be prepared for everything. You can do with them whatever you want. They should just be robust enough to handle it. Also include exception handling and logging, because there's no more possibility to manually do anything during that deployment. It needs to be in your migration scripts and everything needs to be in there. Let's go to step 2 and have a look into testing. What are the preconditions for testing if you want to automate your deployment? We are here, after coding in the testing step. The first precondition is you need to know if you can trust your artifacts in your mainline. The mainline is the trunk of your version control. You will have many scripts in your master branch or in your trunk and need to regularly test if all those scripts together still build a running application. Therefore, you will need to build every new commit of your mainline. This means deploying all the artifacts you know to know if they work. So deploying all the artifacts to get an installation of your application. And this deploying of all the artifacts is done when a new commit on your mainline happens. Then you should trigger a master build pipeline that you can build on any continuous integration server you want, more or less. There are hundreds of different continuous integration servers available. Just choose the one that fits your needs best. And this master build pipeline then deploys all the artifacts on a clean environment. The result is you know if everything on master is working properly. This is important to know if for any further development. If your artifacts are in an invalid state, you will first have to fix the existing problems, and that will slow you down. So if you know all the artifacts in your master are fine, you can just develop in peace. Now, when your mainline is integrated, you know that your trunk is working fine and all the artifacts in the trunk are working fine together. But what's about the newly developed features in your feature branches? To test them, you should integrate also your pull requests. So if you have your feature branch here in green and make a pull request, The integration will start and test if your new functionality is deployable. You can do this in most continuous integration tools with pull requests trigger that will build the pull request automatically when a new pull request is made or a new commit to an existing pull request is added. When the installation is successful, you can then merge your branch into the master. Now we have two types of pipelines, the master build pipeline and the pull request build pipeline. If you already have unit tests in your application, you can add the unit tests to the build pipelines. They then get executed after the installation of the artifacts and make your build self-testing. So pipelines are a precondition if you want to have automated testing in your software process. Of course, you can have unit tests without the pipelines, but if you have unit tests, but you don't have build pipelines, to run them automatically, you probably have too many manual tasks because you need to trigger the unit tests manually. And if you have pipelines, this is automatically done for you. Remember that your test artifacts are only deployed in test environments. They don't belong into production. This could slow your application down. So test artifacts only belong into test environments. And your tests also belong into your version control. They have to be deployed together with your regular application code. Now, build pipelines with automated tests are nothing else than continuous integration. As you can see in this picture, the developer checks in code into the source control repository. From there on, the continuous integration server is triggered, and that server runs the build pipeline. It executes the unit tests and shows you the result if everything went fine. With a process like this, you get faster feedback if your developed code is in the working state or not. You get directly informed about the state of your code. I used the word build a lot when I talked about the installation of source code. Well, database source code is a bit different from Java source code or any other source code because we don't have the possibility to just build an artifact like a WAR file before we deploy. When deploying database code or also infrastructure code, you always have an installation or a deployment. So a build and a deployment are really the same thing from a database point of view. That's why I use those two words in parallel. It's just because they are in this scenario the same case. Now you have your build pipelines that contain automated tests. To be sure that those changes you made in your code are working in production, it is important to test in a clone of the production environment. If you can't, it needs to be as close to the real production environment as possible. If your test environment is completely different, you cannot make a reliable test that tells you if your migrations will work well because it's a bit alien. You don't know anything about the performance of your migration or updates if your test in an environment that has a different amount of data in it or runs on a different version or is just different. Try to keep those environments as close as possible to prevent surprises when you go into production. Now, what are the preconditions for reviewing? We are in the last step before the deployment. Science says that lightweight processes such as intra-team code reviews with deployment pipelines are more stable than a central change advisory board. You might know from your own company those central change advisory boards that once a week decide which changes make it to production and which ones aren't making it to production. Those decisions are mostly made without the people who decide actually testing the changes. So they just decide. That's also why code reviews based on pipelines and reviews from colleagues result in a way better decision if a change should go into production or not, because those people can actually see what tests were run and what the build pipeline says about the change, if it worked or not, what the integration was, all those things. Now, before you can start reviewing your code with your colleagues, you need to have a common understanding of what your coding guidelines are. If you don't agree of a set of defined guidelines and rules, your code review will be doomed from the beginning, because people have very strong opinions about their code and how it should look like. That's why it is so important to have this minimal set of guidelines in place, like formatting or how you name your variables, how your package naming is, if you do comments on your code, when do you do comments and how, if you use file headers or not, or if you want to use any headers. You should also define how logging is used and what you are going to log, so what the standards are, and also what the exception handling is. And against this set of guidelines, you can then review your code, the code of your colleagues, because you have something to argue about. You should also make sure that every change on your code is reviewed. Also, if it is only a small change that possibly does no harm, 4 eyes are always better than 2. Additionally, if you review code and you are also doing some sort of know-how transfer, because the other person that looks at your code then knows what the change is about and why it is done. So know-how is transferred in reviews as well. So it's basically your job that no change goes into production if not at least one other developer has looked at it. This also means that changes are not made directly into the master branch or your trunk, because they cannot be properly reviewed. And you don't get informed about changes that are directly on the trunk. Whenever possible, look that you use pull requests and the functionality that your version control server gives you or provides you. Most version control servers offer great possibilities for reviewing changes of other people. You should also have a set of default reviewers for pull requests if you can. So developers have a predefined set of other developers that will look at their code. And if you review code, work with comments on the changes if you have questions or propositions about the code. Don't leave your review tool and use emails instead to get the feedback or to provide feedback. Here again, you should have as few switches of tools as possible. And remember, be nice when you review code to other people. Ask questions if you are unsure about their intentions, and don't be rude. Everyone writes bad code, and the best you can do is making suggestions for improvements nicely. Let's have a look at our main process step, the deployment step, when functionality is installed in other environments, where the actual magic happens. This is the point where you promote your code through your pipeline, from development to a test environment, to an integration environment, and then finally into production. Let's have another look at the science behind the process. It is proven that where code deployments are most painful, you will also find the poorest organizational performance. This means that if your deployment process lacks efficiency and has an inefficient process, your whole organization probably lacks efficiency, and they probably also lack proper processes. That is why it is even more important to work on how you work, because it will improve how your organization works. And therefore, the software delivery performance positively impacts organizational performance. If you are able to deliver your software frequently and in small packages with a small amount of functionality, as we said before, that will positively impact how your whole organization is working. And not only has advantages for you, again, there is no business without IT, so your organization will also profit from this. Now, we already have our test pipelines from our test steps, the master build pipeline and the pull request build pipeline. Those two should deploy into something like a sandbox because they are integration tests of our branches. At this stage, it would be too early to deploy directly into a real test environment. Now, we need to extend them with deployment pipelines to be able to provision our test environments as well. So the first goal here is to build more pipelines that enable the deployments to our environments. Maybe you have a test and an integration environment. Maybe you only have one test environment and then the production. Maybe you need 2 or 3 pipelines to deploy. Our pipelines finally should look like this. We have first the pull request build pipeline that integrates our pull requests to ensure the new functionality works. We have a master build pipeline that integrates every commit of the mainline once a day to ensure the whole application works. And now we have a third type of pipeline that ensures that we can provision our environments like integration and production with our new functionality. This makes it possible for everyone to deploy at any time. Especially in the current situation where everyone is working from home, this is something you can save you a lot of time because coordination outside the team is no longer necessary when everyone can deploy. What you still have to consider is if your application has business hours and if your deployment is causing any reduction in availability. Then you should probably wait until business hours are over, or you have to look for a time slot where a maintenance window is planned. So we have 2 types of pipelines that are running automatically for testing and one for the deployment. In times like these, where everyone is working from home, all the developers should be able to deploy independently to those test environments. So pipelines should be available for everyone in your team. This way, people get accountable for their actions and they are getting more careful and forward-looking while developing, and also more forward-looking while deploying on their own. Maybe they're not as careful at the beginning as they should, but certainly over time, when they get aware of the importance and the impact of their implementations and actions, they will get to be more careful. Now, if you have pipelines, you probably think if the deployment to my integration environment went well, I can automatically trigger the deployment to production. What could possibly go wrong with this? If the Java people can do that, so can we, you might think. Well, think again. You should never use automated deploy triggers with databases, because if your deployment did something you did not intend that it does, this will promote directly into production if you have automated deploy triggers. And restoring a database application is a bit more work than restoring an application without data. So you should not use automated triggers to go further through the pipeline. Also not in your test environments, because you want to assure in every environment that your deployment did what you wanted to do before promoting the changes further. Additionally, a rolling forward strategy, where you just correct stuff with your next package, is not always possible. Once data is gone, it's gone. At least you cannot restore it with shipping a new feature. That's not going to fix it. That's why we need to be able to stop migrations if they don't work as expected. And the earlier we notice, the less damage we have to fix. So after each deployment to a new environment, check manually if the deployment did what it should have done, and then promote it with a manual trigger to the next environment. This then looks a bit like this. And we finally are where we wanted to go. We have a continuous delivery process with manual promotions through the pipeline. After the continuous integration, we manually trigger the installation to the test environment, make sure that it works as planned, install it to an integration environment, make sure that it works, and then go into production with another manual trigger when the environment is ready for our installation. This could have been our old development workflow and deployment workflow, where you have a lot of handoffs at every stage of promoting your changes through the pipeline. You hand them to the person that does the test installation, to the person that does the release for you, and then you hand it to the operation. The new workflow that we now have looks a lot like this. The development team maintains the control over their code until it reaches production and is able to know how the code is behaving. There are no handoffs anymore because it's all within the team. Now, only having automated deployments is not enough. We also need to make them robust. Things can always go sideways. We have talked about that already. If things go sideways, it is important to have a plan B and a backup and restore plan at hand. This might involve the DBA or other departments that ensure the system reliability. If you are automating stuff, get those people on board. They are able to help you and you will profit a lot from them. Automate things like setting restore points for database flashbacks, for example, before you deploy your changes. That's very important because if you don't look at backup and restore before you do automation, you're not sure how it works. Make also sure your deployment applies to the company's security standards. It's nice if everyone is able to deploy, but should everyone be able to deploy? Probably not. Change management is also an issue. How do you handle change requests if the company needs them? How do you automate that in your deployment? You might also consider compliance as a factor, or how you need to set up your logging to fulfill the company standards. Same thing for traceability that the teams need, the documentation of the process, and the transparency. There are a lot of questions that you need to answer before you automate your process. Now let's go to our last step of the software engineering process. What do we need? What do we need in regard to monitoring? We are at the very end at monitoring step. Science says that the visualization of work contributes to the software delivery performance. This not only applies to the planned tasks that you have, but also to the tasks that you are going through your deployment pipeline. What is their status of your deployment tasks? How is your build or your deployment going at the moment? Therefore, we need to visualize build and deployment outcomes, make them transparent to the team and to every developer. So when a deployment or a build fails, the team has to be informed about it. You can do this with sending mails. You can use a build monitor that shows an overview of all your builds, of your applications. And you can also integrate your continuous integration server with your version control server so that the build status appears next to the branches and you see always what their status is. But now when we have machine deployments, the developers no longer get this direct feedback. So they should also get informed in some way when something is not right. You should also track which features are deployed on which environment. Especially if you have to do hotfixes on production, You might then distribute them as well on the test environments. Or did someone forget to do this? With tracking with which version is where, you can easily get an overview about this and if something was missed here. Also important is that deployments are distributed, especially in the current situation. Everyone is at home. Monitoring and alerting keeps everyone up to date with what is going on. But don't overdo this. Alerts are alerts and should only alert people if they need to take action. No need to inform about every successful deployment, for example. Now, how do we measure if we get better with automated deployments? There are a couple of measurements that you can use to track your process. The first one is the deployment speed. The deployment speed shows us the time a deployment needs to go through the pipeline. So the time your package needs to go from development to test to pre-production until it reaches production. This measure should get faster over time when you start automating. The second measure is the amount of deployments that fails when you are installing them in your test environments and production environments. This number should decrease over time as well when you are automating your deployment. Installations should get more reliable over time, and if they fail, they should fail early. So in your pull requests or the first test installation. The third measure is the change volumes of your packages. For example, you can count the total lines of new code that are shipped or the functionalities in a deployment to production. This should get smaller over time. We don't want to have large packages, but more small packages to reduce this risk. The fourth measure is the deployment frequency. We count how often do deployments happen in production. Do they happen once a week? Or are we faster and deployments to production happen every day? This measurement should increase over time. We should be able to make more deployments to production over time. Why should we consider measuring things? Why bother about that? Since the software delivery performance impacts the whole organization, with measurements, we monitor also the organizational health. We want to measure the progress that we are making during our automation. And if we need to make adjustments, we need to know when to do them. So to stay on track, we need these measurements. We want to see patterns also over time. Is our progress linear, or do we have setbacks? Measurements will tell us. They also make it possible to solve problems when they first appear and at the right time. Now, how should you proceed if you want to automate deployments in your team? What should your first step be? The most important thing is start small. Baby steps. Set the baselines with version control and probably reviews, and then let the people get used to those changes before you introduce a whole bunch of new ones. Because people need some time to adapt to new things, so don't overwhelm them. And if you achieve something, then go celebrate it. It will motivate people to improve again. You will usually have 3 groups of people when you are automating. The ones that love your new things, you will not have many of them. The ones that are very critical, that's the majority of the people. And you have a third group, the ones that hate it. Hopefully only a few of them. Give the first 2 groups the chance to get used to the new system and get them on board. The third group is hard to convince. They will either get used to it or forever hate it. You probably cannot change this. And if you have automated everything, that leaves a lot of time more for you and the team to focus on the important tasks. So now do you have any questions? Let's have a look at the Q&A. I see some of them. First one is, do you have any preferences for an IDE in combination with Git? From Jonas. Yes, I have. I work a lot with DataGrip when I develop PL SQL. That's my favorite because I just, yeah, lots of people use SQL Developer, but the integration with Git isn't working properly there. So I use DataGrip whenever I can. And if I do some Java development, I use IntelliJ. So those two are definitely my favorites. I also had projects where I used Visual Studio Code. That also works very well with PL SQL and with Git. So Visual Studio Code would be also one IDE you could have a look at. So next question is, what tools are you using for deployment? I use a lot of Jenkins pipelines. It's very common to use Jenkins. Some customers have TeamCity that also works quite well. And as I've said, there are tons of continuous integration servers to build those pipelines with. I also worked with Circle CI that also works quite well. But yeah, mostly Jenkins. Third questions. I think all these features are available in Oracle Developer Cloud Service. Is it correct? I'm not sure about that. Okay, Johnny?
I have no idea, sorry. I guess you can do a bunch of things, but I could not really say that you can really cover all these aspects that you presented about.
Okay. Yeah, I'm not sure about it. How about, the next question is, how about a dedicated environment for each developer? That can be created very fast with just objects and minimum amount of data, such as lookup data. Do you use that approach, and do you think it is a good and needed practice? Well, that depends on the amount of developers that you have. Of course, if there's the possibility that you destroy stuff from other developers when you're developing things, it certainly makes sense to have dedicated environments. I have also seen that. But mostly when you have large applications, as I said, I work also with data warehouses. It's mostly not necessary to have a dedicated environment because the thing per se is huge enough that you can split the work, that no one will do stuff that the others are involved with. But it certainly, can be a good thing to have dedicated environments. That's true. Another question is there a vendor or tooling that can assist with the database development lifecycle? From standardizing the code to adding the changes to source control, from SSMS, all the way to integrating with CI/CD systems for automating and test. I don't know. I don't know of one tool. Standardizing the code, you can use static code analysis tools to do that for you, but those are all different tools. I have not seen one that does it all. CI/CD systems as well, there are hundreds of it. And test, if you have PL SQL, use UTPL SQL for your unit tests. But it's all other frameworks and tools. I haven't seen one. Maybe someone else knows one, maybe later. Next question is, a client is trying to implement a continuous delivery through blue and green paradigm using only one production database and a CVS system. Any generic suggestions, or if you want to share any suggestions? Blue-green deployments, for all those that don't know about them, are you have two productions and then switch productions so you don't have downtime. That's a very cool approach to minimize downtime and make your application very reliable. So you have always one that can be under production, under construction, and then switch. Any generic suggestions? No, but you should test it beforehand. Some sandbox for the test would still be appropriate, I think. Not only have production is always a bit risky. So what do we have else? What CIC tool do you use in your environment? I answered that before. I think this automation seems like a developer on GitHub project, but from DBAs, how to use it. So is the question, I assume the question is, how should DBAs use this? The same way, in my opinion, also DBAs should think about the automation of the setup or provisioning of their databases, like Ansible or some similar stuff. And they should use also version control and pipelines to set this up. Same thing. Do you use tools like Liquibase or FlyWayDB for deploying DB changes? Yes, I have used FlyWayDB before because the functionality is pretty good. Mostly I only use parts of it, so not the whole framework, only certain Maven dependencies if I automate stuff. Because Flyway has this feature of doing checksums over my whole database. And if there are manual changes to the database, this checksum will be damaged, and automated deployments with Flyway are then no longer possible. That's why I only use certain functionalities of the framework and not the whole one. But both work pretty good, and I see them a lot, but mostly in Java applications. Can you repeat the name of the tools that you are using when you work with PL SQL, who is similar with Git? Not sure what that was. For testing, the tools I mentioned, I think, is UTPL SQL. But with PL SQL and Git, I use Git. There are many version control systems, but I'm sure you can use any of them, and not only Git will work. There are also Mercurial or SVN or anything. Okay, Johnny, how much more time do we have for questions? It's 2 minutes.
If you can still take like 1 minute and a half, and then the other one you can answer by text, by writing the answers.
Okay.
So while Camille is doing the talk, you can keep writing.
Okay, I will answer the next questions, and then Camille can take over.
Yeah, thank you.
Okay, some systems like data warehouses can be very large. How to deal with situations where systems can't be just rebuilt on demand from source because it's too big. Yeah, when systems are too big, like data warehouses, you can always clone them. That should be fairly possible. And if you have to deploy all your code and that takes too long during the day, you can also do that overnight, or then just make a clone of your production and do the incremental tests of your pull requests. That gives you at least the possibility to test if your new features are working fine, even if you then don't test your whole system. Okay, then I give over to Camille and answer the rest of the question in writing.